Hello, everyone, and welcome to Treon first webinar of 2026. I'm Edouard Rambaud, Sales Manager at Treon, and I will be the moderator for today's webinar. Today, we will see how AI transforms maintenance going from reactive to predictive maintenance. And during this webinar, we will go through the following topics. First of all, we will present the path from reactive to predictive maintenance. Next, we are going to give a Treon flow overview illustrated with a customer case. Finally, we will cover why predictive maintenance matters and what will happen next. Following the presentation, we will have a Q&A session. So when you have questions, please input them by clicking in the Q&A section in the top ribbon in Teams. And those questions will be answered by our speakers. And it's now the perfect time to actually introduce our speakers for today. Our first speaker is Tom Norman. Tom is Treon Senior Vice President of Sales and leading Treon Sales globally. Tom is a passionate IoT entrepreneur, leader, marketer, and sales executive with big experience at Silicon Labs and Blue Giga. And we also welcome today our guest speaker, Michael De Maria, who is Director of Product Management for Condition Monitoring at the Fluke Corporation. Michael is leading the strategy for AI-driven software and service solution with a very strong focus on scaling predictive maintenance. So now it's time for me to leave the floor to Tom.
Hello, everyone. I'm excited to talk with you about the reactive to predictive maintenance. And I have sliced my presentation the way that we go first a little bit about the overall trends, and then we look at the actual Treon Flow solution. So when you think about the predictive maintenance in general, the kind of the mega trends that drive towards the prescriptive maintenance, which is in the future, is of course the people want to optimize their operations. There is a less workforce available. There are such things as dark factories. Automation is increasing, and the era of AI and self-learning systems makes it possible. So when you think about that, you started from the completely reactive maintenance. You didn't have even a schedule to situation where you go towards to predictive maintenance. The AI really has a big role in the predictive maintenance, and the pretty advanced AI that we see today has a massive role on especially in the predictive maintenance. But we are moving towards the era of superior AI, whatever that is. It's something that is going to make the predictive maintenance on steroids, so you can actually go towards the prescriptive maintenance in the near future. So when McKinsey kind of studied the manufacturing trends, the AI is a leading use case and enable 20 to 30% cost reduction and up to 70% less unplanned downtime. So predictive maintenance and AI is really a good friend for each other. And when you think about the road ahead of us, how does it look like today? Is that you can get an AI events. Self-learning systems, they can actually learn the patterns, and it can create your AI event. And you kind of don't need to set the thresholds necessarily by hand. So systems are learning. This is possible today. So what's next is we're moving towards AI recommendations. So it basically means fault characterization. So systems can actually recommend you what to do instead of just giving you information, and it can optimize your workflow. And followed by that, the story will continue even towards more amazing systems. And when you think about generative conversational AI diagnostics, that's on the horizon. and also the AI is integrated into all layers of systems. What you can call it is physical AI or spatial AI. These kind of things are coming. These are pretty advanced systems, and that gives you contextual awareness. And this is where Treon is heading with our current roadmap. So when you look at the Treon solutions, we have 3 pillars. So logically, you can think about this on the left-hand side, Treon Make. This is for Treon for manufacturing. So you're manufacturing something, you want to make sure that your devices are monitored. We have that solution. Today, we're going to talk about the middle one, which is Treon Flow. This is the solution that is previously called Amazon Monitron. This is inherited by us. We put it on steroids, integrated that with the Treon Connect platform and with the hybrid sensor solution that you can use multiple sensors from the different platform as a one. And then we have Treon Move. This is quite different business than predictive maintenance, but it has the same laws of physics, so to say. So you need to keep your wheels rolling. So you make, you flow, and then you move. And the flow is really good for, we call it material handling applications, conveyor belts, and so forth. So now I'm going to talk about a little bit more about the Treon Flow. So the Treon Flow, previously known as Amazon Monitron, this is really when you kind of ask from the top-notch vibration experts, they might think that this is too simple. But when you talk about with the business manager, they love it. They love it because it's simple, it's cheap, huge value, very affordable, and it's easy to deploy. It's self-learning AI and it's technician friendly. So on the right-hand side, you can see how that actually going to look like. Is that the guy has mobile on his hand, mobile workflows, and you can actually get push notifications from the AI alerts when something is going sideways. So this is definitely going to help you to reach 100% uptime. So here is one use case. This is a real company that is using this system. The kind of they have pretty massive operation ongoing. So, and if you have a massive operation ongoing, also predictive maintenance cost can be pretty massive. So with this system that we are offering, you can do a pretty affordable, pretty wide scale implementation and prevent failure. So in this situation, their single failure can be up to 100K. When you attach the sensors on the bearings and the motors, and you can of course detect what's going on, and the outcome can be that you actually are not seeing the downtime. You seeing the return of investment in just with a single incident within a few months. So this is something that we're super proud of, and this is something that we are expanding to do with several other people as well. So how does this system works actually is what I love about. We are talking about physical connectivity of the real devices. This is not just digital world. So sensor goes and attach on the device. You have a gateways. The gateways are connected to the network through the mobile network. Actually, you can be completely isolated from the operational network. You can use Wi-Fi and Ethernet. Then we have Treon Connect backend. We host this in Amazon AWS, and over there you can actually integrate it with your other systems, CMMS system and so forth, or you can actually use it as it is. So there is both options. You can use it, basic functionality is in the app built in, or you can actually integrate that with the MQTT or with the REST APIs, so-called web APIs. And of course, we have the mobile app, as we are all Nokia people, founded by Nokia executives. So of course, we have a state-of-the-art mobile app that you can use as well for managing your operations. So when you look at the installation of the whole system, so you have a motor where you need to attach the sensor. So you attach the sensor, you glue it over there with surface, and you provision that with the NFC, with the mobile app. You provision the system, it forms the connection. You put it on a backend with the name and location. So you kind of initiate that to the system. Then the AI training starts. It takes typically about 3 weeks that the AI has completely learned how the vibration environment is for that specific device. Of course, it's going to learn the device as it's on its condition, and then it's going to monitor that. And when that is done, it actually, if you think about the device, a brand new device, brand new motor, brand new gearbox, it's in a great condition. Of course, it is brand new. So, and if you attach a sensor over there, everything is good. So the 3 weeks learning period, what we have creates AI threshold. So when you have the threshold, and on this axis, you have asset age. The asset starts to aging. At some point, you're actually gonna have a problem. So of course you can prevent this problem by just simply changing or maintaining the things. But this is not necessarily always possible, and not everybody wants to do it. It depends how you run your operations. But our system can actually catch these aging and the problems. What is about to happen? It can give a warning, it can give an alert, and what actually it can prevent the asset functional failure. And of course, that's how you do the return of investment here, is that you prevent that downtime, or you actually optimize also your maintenance, that you don't necessarily always maintain all the devices per schedule if everything looks good. And you can also use other instruments to kind of like what Michael has from the Fluke to kind of talk about the kind of how you do a more in-depth analysis with the instruments that are designed for this purpose. So this is a real example. This is a real. I wanted to put this on the context that like how this looks like in the real life. So this is the kind of customer for us that have multiple warnings, 3 of them over 4 months period of time. They kind of, when the first warning came, they kind of went and checked the device, and they saw mild wear over there. They didn't fix it. They had a second warning, and this warning starts to come. And after third warning, they went and actually fixed the device, which is the maintenance. They changed the parts for the bearings and shaft, and then of course the device, the vibration sensor, what we have, wireless vibration sensor, what is attached to this device, caught on a normal trend line, and everything was good. Okay, but what happens when people are actually having these warnings? Wanted to talk about a little bit the workflow. So you have here the sensor, you have the problem. The problem is being identified. Something goes sideways, temperature, vibration. You can push the message on this the site manager, for example, and they can assign the task for a person, technician, for example. So which is Mike in this situation. So Mike takes the ticket and inspects that and closes the alert and puts the reason on the system. And then the team, of course, who is a site manager, knows that this been fixed. We prevent the downtime. We kind of just do our tricks over there to keep everything up and running, and we are good. And so this is also very simple workflow application to capture this. If you just really want to kind of have a super simple, clean, easy to go solution, we have that on a mobile as well. It's both web app on the treonconnect.com, or then in a mobile. So if you want to check the mobile app, you can download, just search for Treon. And with that mobile app, as I told you, can provision things. You can see a lot of things as well over there. Okay, when you think about the the Treon Connect platform as what we have developed. So all of those three solutions, the Treon Make, Treon Flow, Treon Move, works on Treon Connect platform. So, and those different applications are bringing you different functionalities. So really a full-blown solution from the sensors to full-blown network, middleware, network management, and applications. Everything is available. And what we are so proud of here at Treon is our quality of our sensors, which is top-notch. And really like this is the really like you don't do a lot with AI if you don't have a high-quality data. And this is something that we bring through our systems. So, and just want to remind that there is an integration layer. So you can actually integrate from the middleware what we have. So our platform is open, so you can integrate it with any system, any third-party system, take data from there and put it on your own CMMS system if you wish, or any other systems. And what we are doing, our vision is to enable AI actually on all of these layers. And very excited about that roadmap in the future that we kind of not just doing the horizontally, but vertically also the AI integration. So how to get started? As you kind of realized, I'm a sales guy here, SVP sales. So I of course want to recommend if you want to try this out, how to get started. We have the starter kit with 10 sensors, gateways, and full-blown hosted system, good to go with you to an AWS marketplace. If you don't want to use that, we are open to of course serve that to you by other means, but that's available, really affordable, even 50 measurement points, $7,600. So really affordable to kind of do a large scale evaluation of the system. All right, that's my part. I welcome Michael.
Thanks a lot. Thanks a lot, Tom, for presenting the business impact going from reactive to predictive maintenance, and how Treon Flow is the simplest solution to scale quickly to predictive maintenance. So now we'll have a discussion with Michael on why predictive maintenance matters and what will come next. So welcome, Michael. Can you hear me?
Yeah, I can. Thank you.
Okay, how are you?
Doing really well, thank you. Appreciate you guys having me here.
Yeah, we're very glad also to have you today with us. So Michael, I jump straight in the discussion. I have a first question. Why does predictive maintenance matter more today than it did a few years ago?
It's a great question. There's from several years ago to today, there's been a lot of things that I think have changed dramatically in plants today. So there's the operations of plants have really kind of changed a lot over the years. If you think kind of way back, there used to be actually maintenance shifts that maintain plants machinery and the like that are becoming fewer and fewer. Plants operate generally kind of around the clock. So how the plants approach maintenance and predictive maintenance really kind of plays a part in that, being able to get more value out of what you're through technology that you couldn't necessarily afford before, but you had more resources and time to be able to circumvent that kind of approach. I think the second thing would be there's a lot more complexity to machines today that didn't exist as many years ago. Machines were really straightforward. Motors were generally start-stop. Now we have a lot more variability in how the machines operate. So kind of the approach then to predictive maintenance has to adapt to that. And then the ability to actually manage and maintain those machines has a bit of a different skill set that's kind of required. So predictive maintenance today has more technical requirements than they did several years ago. The value of those assets actually has changed significantly as well. where you might have, a handful of critical machines and a lot of secondary machines, a lot of redundant machinery. And today you don't. So again, plants operating kind of more around the clock, you don't have that kind of luxury of just being able to swap from one machine to another. So understanding, the faults as they kind of develop and what needs to happen, those risks to production is more paramount in the maintenance department. And so predictive maintenance really kind of has to adapt to be able to understand that. I think the last one that Tom referenced is the subject matter experts within the workforce. This is kind of changed over the years. So how maintenance departments have to use more, get more out of the fewer that they have available to them. And the amount of data that they're gathering is drastically different today than it was just even a few years ago. So higher volumes of data, fewer resources to actually be able to manage that data has put tremendous burdens on the maintenance department. So predictive maintenance has evolved significantly over the years, and plants have had to evolve with that, with a lot of complications that's come.
Okay, thanks a lot. So many complication, the experts that are evolving, yeah. And so about the concrete impact of the downtime in the factories, what are some typical challenges and bottlenecks that your customers face due to downtime?
I think there's a lot of things that customers, or just plants in general, so not necessarily just our customers, but this is kind of general for plant managers in general. So it's that proper planning, I think, that has become a kind of a significant challenge, that kind of the bottleneck. It's easy to find a machine that is in its last legs. It's gonna scream at you. It's very apparent that, hey, this machine has a problem. You don't need sensors on a machine to tell you it's about ready to fall apart. But how do we get enough information ahead of time in order to circumvent that problem long before it exists? If you look at, how you do analysis, there's people reference like the big three. It's kind of easy to kind of look at some fundamental problems that a machine might experience, but it's those underlying faults, those root causes that develop early. So how do we get enough information in order to prevent the downtime long in advance? So, and when there is going to be downtime, how do you know exactly what it is that you need to do in order to fix it? And then making sure that you have everything on hand, so you're not waiting for the machine to fail and then scrambling to figure out what to do. The other, the big bottleneck, I mentioned this before, is there's the staffing shortages that companies are facing. So there is more to be done from fewer people that are out there, which creates then that bottleneck. You have a lot more data, fewer people to look at it, more decisions that have to be made. So you can lessen the requirements of the system to say, hey, I'm only going to look for like significant faults that exist in a machine and not the emerging faults. And that just leads back to that first one, that you don't really have enough time to plan for it. I think the third one, I'm going to go back to one of the slides that Tom had, which is the case study. It's a fantastic slide. I don't think enough plants do that. And it's a challenge that I think plants face, because predictive maintenance is part of a tool in a maintenance toolbox, and they're just finding problems and solving them. And there isn't enough time, I think, spent to go back and say, hey, this is what we found, this is what we solved, this is how much we saved, these were the risks, that you make a business case that says, hey, we're on the right track. We have objectives of our predictive maintenance program, and we're meeting the objectives. So putting those types of case studies together I'm not sure if we count that as into a bottleneck, but it's certainly a challenge that companies face in being able to demonstrate the value of why they're investing in predictive maintenance to begin with.
Yeah, definitely. And well, but this will come for sure as a trend as AI is coming on this. And I have a question for you on the AI topic. How do AI-enabled maintenance solutions will differ from traditional, or actually differ already from traditional or non-AI approaches?
Okay, AI is inevitable that I mean, it's been around for quite some time now. We have applied AI to how we do machinery analysis for many years. And it happens on a lot of different levels within it. So one being the complexity of a machine, as a good example. If we are only trying to solve for, again, those big three that I have imbalance and misalignment, bearing wear, I have shaft-related issues and I have bearing-related issues, it's easier to analyze those things. But machines fail 1,000 times more ways than that. So, and machines are way more complicated. They're complex machinery. It produces complex vibration. So it's how do we get enough information about how the machines operate in order to train the AI to begin with? So understanding the nuances, the internal designs, the components, gear mesh frequencies, motor bar frequencies, things like this, things that contribute to the way that a machine can fail. So as Tom presented the trend of crossing over a threshold, it's how much information do you have to understand where that threshold should be defined. So that's another area where AI assists in an analyst to understand when does attention need to be made and how do they gather enough information and package it in a way for an analyst to make those decisions. So those details. So AI is intended to aid an analyst and be able to say, hey, we're missing the details about the machinery. Let's use an AI to try to fill in those gaps. It's used to say, these are the different ways that the machine runs and produces vibration. And every machine is like a fingerprint, so it produces its own. So how do we define where those thresholds should be? And it's just not, it's a simple chart and a single line, but that's in reality not the case. A machine, all the different fault modes have their own thresholds for how you're going to cross over it. And then it's about making those decisions early. So can an AI, we use AI to, once we've identified the machine components and we've set thresholds for all the different ways it can fail, then the AI then really streamlines the workflow for the human that's going to get involved, packaging it up in a way and says, hey, you now need to jump in here and make a decision. So how do we get that early? And again, not waiting until a machine is now crossed over and is making a tremendous amount of vibration that's going to make it very hard for a human to make a decision, but packaging it in ways for there to be an easy path. Again, lots of machines, lots of data volume, and it has to be presented in a way that is manageable by the human that's going to jump in.
Okay, so now we have covered first the predictive maintenance matter today and before. We checked then the impact of the downtime in the factories. We went now to the AI topic, but on the evolution of maintenance, how Fluke sees it. What does the future-ready maintenance look like on Fluke's horizon?
Yeah, it's a great question. I think it goes back again to Tom's slide where he's talking about Tim, then Mike, and then Tim again. So think about Mike in the middle, not me, but a different Mike. There's a need to be able to have a human involved there, to be able to I think the way it was phrased was like a troubleshoot and then repair. I'm paraphrasing. So how do you then add more data be able to understand really then what needs to happen in order to fix a machine. There's a lot of different technology that's out there. So wireless sensors, and we love wireless sensors from Treon because it produces a lot of data that you would typically displace from a route-based collector. So I have, typical approach where I have a lot of machines and I train a couple of people in the plant to walk around and capture the data from a machine. But plants are trying to step away from that. Machines are dangerous. So can we put technology into place that displaces that route-based data collector? So we have data that's coming in at scale to, again, understand what's happening and build a kind of a path of what's going on. But at some point, you do have machines that you would want to use a route-based collector to capture data on. Some maybe they're easier to get to, or they operate in kind of unique modes. Maybe they subbalance a plant to more cost effective to do route-based collector. Or you have maybe more critical assets. So machines that you need more advanced technology on the machine to make edge-based decisions. So making sure the machine's running in certain conditions before capturing data. Or just you need way more advanced frequency ranges or resolution or requirements for those machines. So one of the things that Fluke has from that vibration perspective is the ability to cover all of your assets, from the balance of plant machines, balance of plants, your critical machines, and everything in between. So using a variety of hardware technologies to capture that data, all using the same application. So from a vibration analyst perspective or the reliability engineer or plant manager, it's a balanced approach. The diagnostic results that come from a machine using one technology is on par with a diagnostic result that comes from your most critical assets. So it's the same diagnostic engine, the same AI system, the same way that data and results are presented to that end user. In addition to Mike using some other type of vibration to troubleshoot maybe what's going on, there's a lot of other technology that a predictive maintenance person will have in their arsenal. Acoustic imaging, infrared thermography, and the like, or have this ability to add. Either it's a contributing factor of this machine is producing vibration. Let's use an IR camera to kind of see if we can validate what's actually happening on the machine. Or it's a machine that doesn't operate in a way that vibration is applicable. Maybe say talking about the electrical connections into a motor. Vibration certainly plays a role in the machine's rotation, but you're going to use infrared here in this case to make those decisions of, is there risk to production? What is happening within all the assets that make our products in the plant? So Fluke has a unique position here of having a lot of technology available to the maintenance department. There's a lot of data that comes in. So Fluke's direction is really to how do we do this at scale? In 2025, we had millions of diagnostic results that our services team delivered to our customers. So it's that operation at scale, putting automation into the mix, again, to leverage AI to fill in the gaps of what do we know about the machine, fill in set those thresholds and those values to say, hey, something needs to happen. And know as data streams into our system, when can we handle everything through automation and when do we have to get a human that's kind of involved? I think the third thing that I would say from on the Fluke side is that there's a need to be able to bring maintenance up from the ground floor. Again, there's a tool there that's used for the maintenance department to find faults and then do repairs. And then ideally they'll use that same tool again to validate the success of those repairs. The machine said, hey, we had to replace the bearings were replaced, and then we collected more data and confirmed that, yeah, the bearings were installed, no additional new faults were introduced. Or we've identified that there might have been a root cause that all needed to be assessed or included into that repair. So making sure that maintenance departments have all those those right things at their arsenal to be able to execute upon it. But then how do we level set that up? So it's a very technical set of data that we're capturing, but we need to turn that into more business speak. How do we turn that into metrics so that decisions are made for how you progress those forward? Are you on track for those objectives? So what is the most common root cause, or how proactive is a plant in the predictive maintenance journey? What are your worst offenders or bad actors? Those types of things that we then add into our program to make sure that the maintenance department is enabled to have what they need to empower all the decision makers within an organization to keep their plant on track for production.
Yeah, bringing the good tools to the maintenance teams. Thanks a lot. Thanks a lot, Michael, for the discussion, your inputs on AI, on predictive maintenance, and Fluke's approach to it. As scheduled at the beginning, let's now jump directly to the Q&A session. I will check now the questions from the Q&A. So the first question that I have is actually for Tom, I think. Where do customers see the fastest wins after using Treon Flow?
Oh, this is interesting question, because I don't think there is a single right answer to this, because predictive maintenance you can also think about as an insurance. So in a way, when you have installed it and it's there, you already have enabled potential to capture the problem. So who knows when the problem comes? Okay, when the problem comes, if it's like I had on my use case, you're gonna definitely benefit of the system, and depending on your manufacturing scale and urgency, even a single prevention can be pretty significantly important for the company, especially the timing. If you're doing some sort of like a high season production, any of these downtimes could be really. I think the biggest win is that you actually get your insurance and get the system and get on this and start learning with this. These are not trouble-free systems, though. You also need to also take care of it. This is a full-blown wireless IoT network, which is low maintenance network, but this is not just like that you install and forget it. You need to also maintain expertise of running it.
Okay. Okay, thanks, Tom. Second question, probably already slightly covered by you, Michael, but still quite worth asking you. I think everyone has this in mind. Will AI take over maintenance analysis, or do we still need human expertise?
We do get this question a lot, and I did kind of I probably alluded to the answer here, but I'm glad somebody asked this question again, kind of more direct. Will AI take over the world? Probably true at some point, but not now. There's a couple ways I think we could think about this. So if you aren't using AI today, I think you're going to be left behind. AI certainly has its place in our day-to-day lives today already. But I think it's pretty quick that you would identify whether or not how much you could trust an AI to a system. Ask AI to create an image for you, I think is a good example, or create a video for you. Those are all kind of fun things to do. And you'll realize pretty quickly that it's hard to get what you have in your mind out of that AI system. It's not going to be on your first prompts. It's probably not even close to what you're thinking. It's probably okay if you start working it with, asking it to help you write, a paper, but it does require a lot of prompts. You do have to keep constantly making sure that you are putting in information in a way that gives you the output that you're expecting, and then steer the course and constantly proof it, because it is not. What I did one yesterday is on I was researching different melting temperatures of materials, and it totally had the values wrong. It blamed that it was trying to convert it to Celsius and from Fahrenheit, and that was its reason for why it was failing, and identifying a temperature was presented as higher, but in reality, when you look at what the numbers it was presenting, it was actually lower. So can you then, now putting it back into the predictive maintenance, would you take down $1 million machine based on that one output? Right? So how willing are you to trust your critical machinery? Or any machinery in a plant has a purpose. So even if it's it's a sub-balance of plant machine, are you willing to take it down and repair it based on an AI alone? And I don't think we're there. I think all of our customers have been very adamant about how do you use AI and its intended, and your guys' intended purpose of it. So as I said, and this is I think where I was kind of alluding to maybe why this question got asked, is I stated that it's a tool for a human. It's a tool for the analyst to be able to get more information out of the system and make decisions faster. So we certainly have trained our system, and I think that's an important point when you think about AI, is if you did ask it to draw a picture for you, it had to have been trained very well. How does Google know how to draw a cat? Well, it's been told 1 billion times this is what a cat looks like, so it has references. You can't rely on waiting for a machine to fail to say, hey, this data is what this failure looked like. How many different ways a machine can fail? How different ways vibration spectrum gets produced in order to generate a fault. It's a tremendous amount, and we're capturing tons and tons of data, but it has to be referenced with reality about how machines produce those faults and how those kind of things trend. So relying on AI alone, if you are looking at a vibration program, understand what's its training references. I've heard stories of, I've just put a spectrum into ChatGPT and say, hey, what do you think? And it might come up with some ideas of what's going on. But you certainly would want some subject matter expert to take a look at that and say, yeah, you're right. How you can't just blindly trust AI today in its outputs. So AI, sure, we are gathering tremendous amount of data in the plants today. Those will certainly feed into AI engines to start making decisions. But it still has to be trained with real world understanding about how machines fail from those data. And then I don't see us in the short term of being able to make significant decisions on machine repairs, especially for critical machines, without having some human eyes that confirms that data.
Yeah, and actually, we have another question that's quite similar. You probably mainly answered it, so it shows how important it is. How close are you to have a fully automated system? Do you see a point in the future where human-in-the-loop policy will not be implemented, or is it something that needs to stay? And I think you answered already that human needs to be here, and it's a tool for the human.
Exactly. Yeah, the AI is there to support the humans. So you still have to have human there that's even if it's going to just making the prompts, right? There's a human always going to be in the loop in the system. The idea, I think I know everybody wants, is I put these sensors on the machine, I turn it on, it self-trains, it's self-learning, it understands everything that could happen about the machine, and it'll make all these decisions for me. But even if that's true, you would still want somebody in that loop that then consumes that information and says, I've looked at it and I agree with it. I mean, we use our human analysts in this kind of this capacity of being able to say, do we have enough information? No, not yet. Keep learning. Can we build thresholds either as overalls or full spectrum to say, hey, we now have a good representation about what's normal and healthy. And when something comes in, if it's underneath those thresholds, sure, we can pull humans out of that loop to say, hey, the system is identifying healthy machines very easily. So then it lowers the burden on the human to say that these are the outliers that you need to take a look at. This machine doesn't quite match the model. What might be wrong? Well, it was starting up, so it produced a lot of vibration that was not normal and expected, but not in reference to what we think the vibration should look like in its normal running state. So it gets flagged, and a human says, "Yay, this data is not good. Let's wait." Or we have a machine that's trending. So flag the human and say, hey, of the thousands of machine sets that came in today, great. Only 10% of them have some sort of issue that you might want to take a look at. So we're significantly lessening the burden on the human by using AI. But that human still needs to be in there for those 10% to say, hey, yeah, there's something really going on.
Yeah, truly agree. I have another question, maybe more for you, Tom. Does the sensors need wiring?
Oh, that's an easy one. I mean, we are fully wireless company, as our heritage is from the history of the companies. The founders, 7 founders, are old Nokia experts and designers of the world first state-of-the-art mobile phones. Decided to connect, instead of connecting people, connecting things, and that's what we are known for, is a really great wireless network sensors. And no, we actually don't have any wireless devices, so it's all wired. So we don't have any wired devices, it's all wireless and battery operated, and try to get everything running 5 years with a battery.
Okay. And do you also provide temperature sensors?
Is this for me or my...
Yeah, sorry, Tom, it's for you.
Yeah, for yes, we have temperature in all of our sensors as well.
Okay. Okay. And another question is, what, probably for you also, Tom, what are the connection requirements? So I believe from the sensor to the gateway.
So it's all wireless. Actually, if you think about the challenging point is typically the gateway. Where do you attach the gateway? So we have a mobile connectivity on the gateway, so you don't need to be on the operational system at all. You can have Wi-Fi or Ethernet. From gateway to sensors, we use multiple technologies for mesh networks, which is multipath mesh network, which is mission critical system, which is really great system. It's been used on systems with really, you need to get your message through, makes it ultra robust. So mesh word networking 2.4 gigahertz, and then BLE is there as well, but that's also 2.4 gigahertz. So all wireless.
Okay. Maybe one last question, Tom, before we close. Do maintenance teams need special training or prior experience to use the solution?
For sure, yes. And I would say the kind of for maintenance team, what my experience is with the maintenance teams is that they they love look, for example. They use the instruments. They know wireless is new to them, depending on a little bit of the company. But how they want to use it. Is it mobile only? Is it how they're going to actually consume the data? Is it email alert? Is it events to your push to your cell phone? How they're going to consume the alerts? How they're going to go and look at it? So the best IoT system is this kind of system that's almost invisible. You don't need to care about it. But that's not reality. You need to be trained a little bit. And of course, when something happens, how do you actually tackle that thing? So we offer, of course, that kind of a training for the maintenance teams, and they need to get familiar with the system. But it's the intention is that it's not a high maintenance system, and it is not. The intention is that it adds value, and the intention is that it's as invisible as possible. So the worst thing what the IoT systems can do is that it bothers you. It doesn't provide value. So focusing on the value is so important.
Okay, great. Thanks a lot. We still have a lot of questions, but we are running out of time. So we will get back to you via email to answer the questions that remain. Also, the recording of the video will be sent out to you soon. And that's it for today. Please feel free to contact us, Tom, Michael, and me and myself. You have here our email address, and as I said, we will send the recording of the video quite soon. So I think we will now stop the webinar. Thanks a lot, Tom. Thanks a lot, Michael, for your time today and for the quality of the presentation. And as said, we'll come back to you quite soon with the video. Thanks a lot. Have a good day, evening.
Thank you. Bye.
Bye.
Thank you.